Thank you so much for coming to this session. We hope that you learn a lot about the concept of costing projects in this session. And so we are all from the University of Illinois in the United States, and we will be talking about costing strategies for affordable fecal sludge management. And we'll be going over the methods of technoeconomic analysis, and we will also be talking about an example techno-economic analysis comparing a pit latrine against a urine diverting dry toilet. And so before we get started, we each want to introduce ourselves. So there's 5 of us total that will be presenting and answering questions today. And so Jeremy will introduce himself first.
So my name is Jeremy Guest. I'm an associate professor at the University of Illinois at Urbana-Champaign. And our research group, among other things, does sustainable design of sanitation and resource recovery technologies. And so in particular, everyone who's on the helping lead the call today has been working on work, for example, for the Bill and Melinda Gates Foundation, doing techno-economic analysis of emerging sanitation technologies and comparing them to existing technologies in countries all over the world. So I'm going to pass it off to Hannah.
Thanks. I'm Hannah. I am a PhD student working with Jeremy at the University of Illinois, and I am studying environmental engineering. And so a lot of my research is focused on costing, but I also consider the environmental impacts of projects and also other decision-making factors. And then now Tori.
Hi, my name is Tori Morgan. I'm a postdoc working with Jeremy and Dr. Roland Cusick, evaluating environmental impacts and costing of sanitation and water treatment technologies.
Hi everyone, my name is Stetson Rolls. I'm also a postdoc here working with Jeremy, also involved in the Gates work.
Hi everyone, my name is Joy. I'm also a PhD student of U of I and studying environmental engineering. I'm also part of the Gates project, and on the side I'm also working on using sensitivity analysis as a method to understand drivers of performances of the systems.
Great, and at the end of the presentation, we'll have all of our emails. So if you have any specific questions for any of us, you can always feel free to email us. And then we also want to utilize the chat. So throughout the presentation, if you have any questions, you can just type your question in the chat, and then one of us will try to answer the question while the presentation is happening. And we'll also have a specific question and answer session at the end too. And so before we get started, we wanted to just kind of understand where you're coming from as far as costing. And so we want to know what your experience is with project costing and techno-economic analysis coming into this workshop. And so if you want to take the time to answer this poll, you can either have no knowledge, so this might be your first time attending a workshop like this or thinking about costing of projects, and you could have basic knowledge or intermediate knowledge, or you might already have advanced knowledge and you fully understand these topics and you've already used the techno-economic analysis tool. And so if you want to answer the polls, I'll take maybe 10 more seconds and then we can share the results. And it's okay if you don't have any knowledge. We're assuming that you don't have a lot of knowledge coming into this, and we'll be going over the basics of TEA in this workshop today. And so if we want to end polling, Joy, did you? Okay, and then we can share the results. And so it looks like about 50% of people say they have basic knowledge. We have 3 people saying they're already an expert. So maybe if you want to take over the presentation, you can do that. And then, yeah, so it seems like a lot of people have a little bit of knowledge, but they could learn a little bit more. And so now I will move on to the first topic. And so this is the outline we'll be discussing today. And so we will be introducing key topics of techno-economic analysis. And then after each individual topic in this list, we'll be taking you to an example techno-economic analysis. Well, we will be comparing a pit latrine against a urine diverting toilet. And so we'll be introducing a topic and then we'll show its application in our example. And we will be providing these slides and a detailed guide of how to do TEA, Technoeconomic Analysis, a example that we've developed in Excel, and then also a reference guide to Python if you wanted to develop these tools in Python. And so we'll be sharing this link in the chat. It's a Google folder, but we can also, I know this session is recorded and you'll be able to receive access to the recording, and so we'll make sure that you have access to the files in that way too. And so first, I will be talking about techno-economic analysis. And so specifically, economic costing is really important for financial decision making. There's not many projects out there where you don't think about how much it will cost to build it. And so a lot of terms thrown around in costing are life cycle costing, techno-economic analysis, and they are very similar, but there are some key differences. And so specifically the definition of life cycle costing is an assessment of all costs associated with the life cycle of a product that are directly covered by any one or more actors within the product life cycle. And so these actors can be the supplier of the materials for the project, the producer and builder of the product, the user and consumer. So these would be the people that maybe are purchasing or using the product. And then the end of life actor. So that would be someone that would take the product after it's already reached the end of its useful life, and then they'll help dispose of it. And then you can also include the externalities that are anticipated to be internalized by the decision relevant future. So that's life cycle costing. And then similarly, techno-economic analysis, it considers the entire life cycle of the project still, but it's also a financial feasibility analysis that integrates the technical aspects of a project with economic analysis. And so here we'll be trying to evaluate the costs, but also incorporate the technical aspects of the product. And then this is also commonly used for marketed products. So as the field of environmental engineering and sanitation shifts more towards resource recovery, we might be recovering resources that we can then use as a new product. And so it makes sense to shift more towards the techno-economic analysis thinking because we're trying to potentially create products that we would be selling. And so now I'll go through the steps of conducting a TEA, Technoeconomic Analysis. We'll be using that acronym throughout. So TEA is just this economic analysis we're talking about. And so I'll go through these different steps, but I won't go into them in detail. That's what we'll be talking about later in the presentation. And so the first couple steps are to identify the objective and system boundary of the TEA and also identify the relevant actors. And so in these steps, some questions that we might answer are, what is the purpose of the TEA? Why are we conducting this? What steps and actors will we include? What steps and actors will we exclude? And so those are some things that you think about in this step. And then the next steps are to identify the costs and revenues. So you already outlined what you will be including and excluding, and now you need to come up with the detailed costs. And so here we want to think about what costs and revenues we should be including in each step of the life cycle. And then you also want to think about the system lifetime and analysis period. And so the pit latrine might have a lifetime of 8 years, and also the urine diverting dry toilet might have a lifetime of 8 years. So maybe we just want to look at it over an 8-year period. But if we plan on replacing it, then maybe we could consider a 16-year period and try to account for that replacement in the halfway point of the analysis period. And then the next step is to link decision variables to costs. So ideally, we would want to be able to understand how costs will change when we change the design. So if we change the size of a part of the product, then how will the costs change as we're changing the shape or size? And then we want to do our economic analysis. And so a lot of the times we do discounted cash flow analysis. And so in this step, we want to think about what is an appropriate discount rate to choose. And so we'll define discount rate later in the presentation. If we're having profits by selling items, what will the income tax be Do we need to include income tax? And then the next step is sensitivity and uncertainty. So if we want to look at a range of values and not just have a single value for our inputs, maybe the price of electricity ranges from one value to the next, how will we account for that? And so questions we might ask are, what are the expected range and values of the results? And then if we have uncertainty, what is driving the uncertainty? And then finally, so this example that we'll be showing you is comparing two toilets in Uganda. But what if we want to change the implementation location? How will the cost change if we move from Uganda to Kenya? And will this project still be affordable if we're trying to build it in a different country? And so those are the basic steps of TEA. And now we just have a check-in question again. We'll be using these to kind of understand what sections we should focus on more in the Q&A session. So if you want to quickly answer this poll, do you understand the basic definition of techno-economic analysis and the steps to conduct it? And you don't have to be an expert on these topics. This is more just, do you kind of understand, or do you need a little bit more definition? And so I'll give you a few more seconds to answer the poll. Okay, I think we can cut it off. Okay, so we're sharing the polls, and 50% said they might have some questions. 3 people said that they have a lot of questions. So specifically the people that have questions, if you want to take some time to ask questions in the chat, we can answer the questions as we go. And now I will move on to the next section. Okay, so now we'll be walking through each individual step. So I highlighted in red what section I'll be talking about in this one. So I'll be talking about how to define the objective of the TEA and the system boundary. And so to define what these are, so the objective is the purpose of the techno-economic analysis. So this is us defining why we even want to conduct a techno-economic analysis. What are we interested in studying? What are our research questions? And then the system boundary is you defining the sources of costs and revenues from the project's life cycle that are included and excluded from the analysis. And so here you're trying to decide what parts of the life cycle you want to include. So you could include maybe your project, you want to include constructing the project and also using the projects, but you don't care about recycling or disposing of the project. So you would be including construction and use, but you would exclude the end of life. And then choosing your costs and revenues. So you have to think about what costs and revenues are included in those phases, what will make an impact. Maybe there's certain aspects that really have marginal costs and you don't think that they will really play a role in your decision. So you have to choose what you want to include and exclude. And so here are some examples of objectives. And so first, for your TEA, you could be interested in just calculating the total cost for a single project. And so you can see in this figure, you're just adding up the total cost of the project. Another objective might be that you want to figure out what is driving the cost of that project and try to figure out how you can cut costs. You can see in this figure, the bar is broken down into different colors, representing a different aspect of the costs. So the costs here are capital, labor, and operation. And so you can see that the largest chunk of the bar is related to operation. So you could understand that operation is potentially driving the costs and you want to figure out how to reduce those operation costs. And then you can also choose the lowest cost alternative of many. And so here you might have 3 different projects that you're comparing and you want to figure out which is the most affordable project. And so you can see that C has the cheapest cost, so that might be the project that you want to choose. And then there's a lot of different other objectives you could identify based on your project needs. And then for the system boundary, there are different phases of the life cycle. And so these 4 boxes identify different phases of the life cycle. So the first is getting the materials and components. So that would be the materials and component supplier. And then they would provide the materials to the product manufacturer. And then the consumers and users would interact with the product, potentially buy it if it was not a free product. And then the end-of-life actors, they would be in charge of disposing of the product, recycling, whatever steps need to take to decommission the product. And then during each phase, you can have costs and revenues occurring between the different phases. And so looking between the product manufacturer and the consumer, the manufacturer might receive a revenue from the consumers because the consumers are purchasing the product. And so this is typically what you can include in the economic system boundary. And you don't have to include everything. So you could just only include the user if you only cared about the life cycle or the technoeconomic analysis from the user's perspective. So you could choose to include and exclude anything from this as long as it makes sense to your project. And then something that's outside of the scope of this presentation, but I will just briefly mention it. You can ignore it if you don't care about it. But if you're interested in how this relates to life cycle assessment and understanding the environmental impacts of a system or the social impacts, this is kind of how the system boundary will relate to the social and natural system. And so layering on top of it, you would see externalities within the social and natural system occurring within that life cycle. And so everything in green, we aren't going to talk about further in this presentation, but we would be happy to answer questions, or if you want to email us, we can talk about it more. And so now I'll introduce the example that we're going to be discussing. And so we'll be comparing two toilets in Uganda for this. And so specifically, our research team has done a lot of work based in Kampala, Uganda, which is the capital of Uganda. And for this study, we're going to assume that we are dealing with a population of 20,000 toilet users. We'll have 4 households per toilet that we'll be constructing, and we'll assume that there's 4 toilet users per household. And so we'll be comparing a pit latrine against a urine diverting dry toilet. And so a pit latrine is very commonly used in Uganda. The urine and feces will be combined in one pit below the toilet. And then a urine diverting dry toilet, sometimes we'll say UDDT, separates the solids from the liquids. So you'll have separate storage from the urine and the feces below the system. And this also allows potential optimized nutrient recovery. So we'll be considering recovering nutrients from the urine of the UDDT. And so the objectives of our TEA for this are to compare the daily user cost of a pit latrine against a urine diverting dry toilet. We want to calculate potential nutrient selling price to offset the cost of a urine diverting dry toilet. We want to calculate the rate of return on investment of a urine diverting dry toilet, assuming we'll have an income from the nutrient selling price and also the user fee. And then we want to evaluate the financial feasibility if we move our implementation location to places such as China, Senegal, South Africa, and India. And then we also want to understand the sensitivity and uncertainty of the model. And so all of these objectives you'll see in the Excel spreadsheet that we'll be providing to you, and we'll also be talking about these specific details in the later slides. And then the system boundary of our TEA. So for each system, we will be including the materials to build the system, operation and maintenance of the system, transportation to a treatment facility. And so for the pit latrine, it will be transporting the latrine contents via truck to a centralized treatment plant. And the urine diverting dry toilet system will use hand carts to collect the storage tanks below the toilet and take them to a more centralized location for trucks to pick up and then take to the treatment plant. And then once at the treatment plant, the trucks operators will pay a fee to dump the contents at the treatment plant. And so that cost covers the costs of the treatment. And then we're excluding end of life, and so we won't be accounting for disposal or decommissioning of the toilets themselves. So now we'll do a quick check-in again. So do you understand how to choose the TEA objective and define a system boundary? So I'll let you take a few seconds to answer this question. Again, these questions are really helpful for us when we're trying to figure out what to talk about during the Q&A session, and it'll also help us answer questions as we go. Okay, I'll give you a couple more seconds. People are still answering. Okay, we can cut it off. Okay, so it looks like a lot of people understand, which is really good. And then some people have some questions. So if you have those questions, go ahead and put them in the chat and we will try to answer them before the Q&A session. But if your questions are answered, you can also ask the questions during our Q&A session at the end. Okay. So now Tori will take over and she'll be talking about cash flow categories.
Hi, thank you, Hannah. So go to the next slide. So in order to organize what you're going to put in your techno-economic analysis, you'll want to think of a cash flow diagram. And what this does is it helps you account for all the revenues and profits that are coming into your analysis and all of the costs and expenses that go out. So you can see in this example cash flow diagram right here, the up arrows are what you will add, which are your revenues and profits. And the down arrows are what you will subtract, which are your cost and expenses throughout the time of your project. And so one example of a revenue or profit might be user fees. Maybe you charge one fee at the beginning, or maybe you charge fees over the lifetime if you're providing a service. Another example is a subsidy. So if the government is trying to achieve some initiative and you help achieve that initiative, you might get money back as a subsidy for your project. And then another example, as we shift from wastewater treatment to waste recovery, is resource recovery. So you can gain revenue on recovering nutrients and selling it as fertilizer, maybe recovering biogas and selling that back to the user as energy, or other types of ways that you can recover resources and make a profit off of it. And then another example is fairly recent, is called carbon credits. So 1 carbon credit equals 1 ton of carbon dioxide emitted. And how this works is that you're given a certain amount of carbon credits. And if you don't use all those carbon credits, you can actually sell that to others that need those carbon credits. Another thing is that you can invest into recovering resources or renewable energy, planting trees, and that will create carbon offsets that will help you gain carbon credits. So we don't talk about that in our specific example, but that is something I just briefly wanted to touch on. And then for expenses and cost, you can think of maybe all the capital costs that incur at the start of your project. So this can be the materials you need to build, and this can also be the land that you need to buy in order for your project. And that can vary depending on the location, like Hannah mentioned earlier. So for land, if you're in an urban setting, it might be more expensive than if you're in a rural setting. So those are things that you'll want to account for in your cash flow diagram. The second is O&M costs, so operation and maintenance. So what do you need in order for your system to maintain itself over the lifetime? So you might need electricity, so that comes with electricity cost. You might need labor, so you might need people to build it at the beginning for construction, but you also might need operators to come throughout to make sure that the system is functioning properly. Maybe you need to dispose of sludge, and so you need to hire people to come and transport the sludge away from a system via hand carts or trucking. There are also other factors that we need to account for in order to calculate net profits. And one of those is depreciation. And that's a reduction in the value of an asset with the pass of time due to the decrease in value of currency as a result of inflation or wear and tear of a technology. And so $1 today does not equal the same amount 10 years from now. The value of money changes over time. So for example, we can see in the year 2011, one United States dollar equals $1.19 today. And that might not seem a lot, but when you have a larger sum of money, that's really going to make an impact over time. So you can see how it changes from 10 United States dollars, 100 United States dollars, and then 1,000 United States dollars is now $1,187.23 for United States dollars. And then another form of depreciation I mentioned is wear and tear of a technology. So if you do want to salvage parts at the end of the project, maybe you bought some electronics. For example, you bought a laptop. So in this example, this is a 2011 MacBook Pro. And at the time it was $1,200, but today it's now about $270. And so if you want to salvage materials or look for the salvage value, you'll need to take that into account as well. We don't do that in our example, but I just wanted to mention it in case you want to do it in your own analysis. And then another factor to account for net profits is the tax rate. And that's the percentage at which an individual or corporation is taxed based on the location. And so usually in our analyses, we look at different countries and see how the tax rate and other contextual factors vary in those countries. So for example, we're looking at the tax rate and corporation from China, Senegal, India, South Africa, and Uganda. And you can see how some tax rates are a lot lower. For example, in China, it's as low as 15%, but can vary up to 25%. But then in Uganda, the tax rate is 30% on corporations. So if you're looking at a specific area, you'll want to make sure that you take that tax rate for the location. So now that we have all of our factors and we have our cash flow diagram, we can calculate our net profit, which is in any given year, the gross profit minus the tax on income. And we can expand that further to see that the net profit is the revenues that we accounted for in the cash flow diagram, minus the expense cash flow streams, minus capital costs. And that's subtracted by the tax rate times revenue minus expenses minus depreciation. And tax on income cannot be negative. And depreciation functions as a tax credit. So we assume things depreciate linearly over the course of their lifetime and have no salvage value. And then annual depreciation equals the capital cost over the lifetime. Let me go next slide. So we can walk through some cash flow streams in our example in the worksheet. And so the first one, we can look at what revenues are we gaining. So one revenue is the daily user fee. So we can look at the daily user fee for the urine diverting dry toilet and the pit latrine and input that as a revenue. The next one is nutrient selling price. So as Hannah mentioned earlier, the urine diverting dry toilet allows us to recover resources, and we can now profit off of recovering those resources to see if we can offset costs. And so that would be another example of revenue. Then we can look at our expenses. So right here are the capital costs of the pit latrine versus the urine diverting dry toilet. And so you can see how the capital cost of the pit latrine is less than the urine diverting dry toilet, and how the costs differ with O&M %. And then the next one is the pit latrine emptying and transport, which is significantly lower than the urine diverting dry toilet emptying and transport. And that's because with the urine diverting dry toilet, you want to make sure that you keep the urine and feces separated so that you can efficiently recover nutrients afterwards. It makes it a lot easier if you separate the streams rather than having them together. So that's why we have hand cart collection and trunk transport, rather just a emptying cost as shown in the pit latrine example. And then, as I mentioned, you need to take in depreciation. So I think this was asked earlier in the chat, but for our example, right here, we're looking at a depreciation period of 8 years. And then we have the taxes and discount rate. And so the discount rate is 5% and the income tax rate is 30%. So after going over the cash flow streams, do you understand how to account for revenue and expense streams and the change in time value of money? So that's a very important thing, is that money does not stay consistent in value over time, and why. Okay, great. So it looks like 72% understand and that 28% have questions. So if you have any questions, feel free to add it in the chat, but I will also dive deeper into net profits in the next section. Oh, do I need to share results? Or, okay, sorry. So now we're going to do costing, look at costing methodologies and outputs. So the first, there's two ways we can look at cash flows. We can look at present worth or annual worth. And so the first option is to resolve all cash flows to their present worth by using the net present value analysis. And you can see in this example, the arrows are flipped, but it doesn't matter which way your arrows go, as long as you have track of your costs and expenses, and then your revenues and profits, you'll get the same answers. So here, they look at initial investment cost, and then they have cost over time, such as replacement, and then they have disposal cost. And then they look at their revenue from the start and then equipment salvage at the end. Next slide. So one thing I want to touch on before we get into the methods is that discount rate is the interest rate used to determine the present value of future cash flows. And so this is informed by inflation. Remember how I said the value of money changes over time. It can be informed by investors, and then it can also be informed by risk opportunity cost. And so we'll take discount rate into our next equation, which is discount factor. And the discount factor is used to calculate the present worth of a future cash flow. So the discount factor is 1 over 1 plus the discount rate to the number of years. So you'll use an exponent, and in the first year, the exponent is 1, the second, it's 2, third, it's 3, and so on and so forth. So the present worth of a future year's net profit is calculating using the discount factor and that net profit that we calculated earlier. So it's the product of discount factor and net profit. The overall net present value includes the construction, which is what you're subtracting from the system, operation, the end of life, which is the sum of the discounted net profit in each year. And then the overall net value is the construction plus the operation. And you want it to equal 0 or set it equal to 0 to see if you're breaking even. So if you are higher, then you might need to offset costs more if you have a negative value. So now we'll see how to calculate the user fee using present worth. And the first thing we'll want to do is calculate the net profit, which remember is the gross profit minus tax on income, or to further expand it, revenues minus expenses minus capital costs, subtracted by the product of tax rate times revenues minus expenses minus depreciation. So first you'll want to calculate the annual revenue. And to do that, you need to know what the daily user fee is. That might be set by the user, or maybe you can set it in your system, the number of users per day, and then days per year. you'll plug the annual revenue into your net profit equation, which is shown here. And you have access to these slides and sheets, so I won't go into super detail with the equations, but just know that you can plug in the annual revenue into your net profit equation. And then once you have your net profit, you can plug that into your overall net value equation by discounting the net profit in each year and subtracting the construction cost from the sum of that. And then by rearranging, you can find the daily user fee that you have to charge per day in order to break even for present worth. Next one, I think there was a typo. Yes, so sorry, this should be, we're going to calculate now the fertilizer selling price using present worth, which is going to look very similar to the user fee. But instead of calculating users per day, we're looking at how much do we get, how much United States dollars do we get per kilogram of nutrients, and see how many kilogram of nutrients we can gain per year. And so you can see the annual revenue is similar. What's different is in blue, you can plug the annual revenue into net profit and then plug the net profit into your overall net value. And again, with algebra, you can find your nutrient selling price, which is again in the document that we've provided. Next slide. So that was the first option, was finding present worth. Another option is to annualize all cash flows. So by doing this, you have a uniform annualized cash flows. Next slide. Or next, yeah. So you analyze any non-annual cost and calculate the equivalent uniform annual cost. So the construction cost is going to be converted from present value to annual value. And the annualized construction is very similar to present worth, but is construction cost times the discount rate and incorporate the lifetime into that equation. And then the non-annual capital replacement cost is converting the future value to the annual value. And you can see it's similar for the capital replacement as well. So now we can calculate the user fee using the annualized cash flow. So again, we're using net profit. And we can calculate the daily user fee by looking at the annualized construction plus the annualized capital replacement that was shown in that slide before, and add it to annual expenses and the tax rate and depreciation, and divide it by the users per day and days per year in order, and the tax rate to get the daily user fee. If we, instead of looking at the daily user fee, so how much we're going to charge each user per day, we can also just look at how much are we going to make in the year, so the total annualized cost. And that's just by multiplying the user fee by the users per day by 365 days in the year. So the question now is to check in and see, how is your understanding of present worth and annual worth analysis? And if you have any questions, feel free to put it in the chat box. One thing to take away is that you can do either one. You're not going to get a different result from one than the other. Okay, now if you want to cut it off. Okay, so it looks like half have more questions and then about 45% understand. I will say that Joy will go deeper into some of this. So she might be able to clarify some of your questions, but again, feel free to put them in chat and we can talk about it also at the end with the Q&A. I don't know. And those are the results. Sorry, I forgot to share. So now I'll let Joy take it away with rate of return.
Thanks, Tori, for showing us how to calculate the daily user fee or nutrient selling price needed to break even the cost. And now I'll introduce another TEA metric, which is rate of return. Next, please. So rate of return, we also formally name it internal rate of return, IRR here, is defined as the discount rate that sets a project's net value to zero. Like before, we can calculate this net value in terms of present worth or annualized worth. And it's often, this variable is often used interchangeably with the annualized rate of return on investment. So on right-hand side is a diagram showing the relation between the discount rate and the net present value of projects. The green line, the steeper line, shows the relation for project 1, and the other one shows for project 2. And we can see that the point where these two lines crosses the x-axis indicates the IRR of these two projects, and one is crossing at about 25%, and the other is crossing at about 38%. So I want to introduce how we can understand this graph and interpret these values we get, because it's defined as the discount rate that sets a project's net value to zero. It generally means IRR is the annual growth rate that the project is expected to generate. And we can also see it as the amount of interest rate we can afford to finance the project and still break even. That means that when we estimate a higher IRR, the project is more profitable. So if we look at the graph on the right-hand side, project 1 has a lower IRR than project 2, which means that project 2 is more profitable than project 1. And if we compare them to a range of interest rate we expect, they both are outside on the right-hand side of that range, meaning that both of these projects are financially feasible, and we can afford those interest rates for to fund these two projects. Next, please. As I mentioned before, we calculate IRR by solving the equations of net present value by setting the net present value or net worth at zero. When we calculate this in terms of present worth, we just need to use the same equation for net present worth. And this IRR will come into play at the discounted net profit in the model, in the equation. As you can see, it's on the denominator of the discounted net profit in each year. And if we want to calculate that in terms of annualized cost, this IRR value or the discount rate will come into play in the term annualized construction cost. And the factor we see on the right-hand side of the equation is just the inverse of the factor we see before that converts present values to annualized values. And we can see that from the nature of these equations, it would be difficult to solve for IRR analytically, but we can resort to software with nonlinear equation solvers or just general programming language. Next, please. Here in our example, we set up the TEA model, and we set up a section here showing how to solve for IRR. What we need to do first is to connect, to set up an equation for net present value, and the discount rate in that equation should be replaced by the cell where you want to put the IRR value. And by using the solver and set the net present worth equal to zero and change reach this zero net worth by changing the IRR values, we will be able to see the IRR. Next, please. And here I'm showing you how to access the functions in Excel that can do this for us. It will be under the data tab and what if analysis and the goal seek function. And in the goal seek window, we can see there are 3 inputs. We need to set a cell to a certain value by changing some other cells. And at the set cell block, we will need to input the cell where we put the net present value equation. And then we set it to value 0 by changing the cell where we put the IRR values and click OK. And then we'll be able to see the IRR this goal seek function solves for us. Next, please. And in addition to just using existing parameters and models, we can change a few constraints that and see what how it affects the IRR it solves. One of the constraints we can consider is the daily user fee, and another one is the nutrient selling price. And I want to clarify that these 2 variables are not the same as the ones we try to solve for. In previous analysis, these 2 are the metrics we use. We fixed the discount rate and other parameters to solve for a daily user fee or a nutrient price so that the project can break even the cost of the project. But here we will set these 2 values as targets. We can specify these 2 values based on what we understand the users are willing to pay, or by observing what are the selling price on the market of similar products. And the relation between these 2 values and the IRR it solves is generally positively correlated, because these 2 are both generating positive streams of cash flow. And if we set a higher target daily user fee, we will generally get a higher IRR. Next, please. Now we've introduced the concept of IRR and just want to check in and see if you can understand the concept of IRR and how to interpret them once we are able to solve for the results. Well, we're seeing we have about 38% of the audience having questions about the interpretation, and some have questions about how to solve it. We can try to demonstrate at the end of the Q&A session, and if you have more specific questions, you can also put it in the chat box and I'll try to address them. Now, let's move on to uncertainty and sensitivity in TA. As we mentioned before, if we fixed parameter values and input it to the TA model, we will get a single point of results. But if we are able to quantify or incorporate uncertainties or the variations in the context, the technology, operation, and design, or deployment options into the model, we'll be able to get a range or an empirical distribution of the TA metrics of interest, which should help us make better decisions. Next, please. And the simplest way to incorporate uncertainty analysis in TA is what we call uncertainty propagation, or it's also sometimes referred to as Monte Carlo method. And to do that, there are 4 steps. The first, we need to identify a list of parameters or variables that are considered uncertain. And we will need to collect data and define a probability distribution for each independent parameters on the list. Once we have the distributions defined, we can generate samples for each the independent parameters. To do that in Excel, we can use the random number generator, the rand function, coupled with the inverse of cumulative distribution function that's available in Excel. For example, here, if we define the household size, a contextual parameter following a normal distribution with mean values of 4 and standard deviation of 1.8, we can use the norm.inf function coupled with the random number generator here, and it gives us a sample from that normal distribution we defined. And we do that many times, and the number of samples we draw, n, is important here, especially when we have a lot of, we have a long list of uncertain parameters. We would like to have this n large so that the sample we draw is representative of the input space. Next, please. Once we have the sample ready, we can just input each row of sample data into the TA model and then record the TA metrics of interest. This process can be automated in Excel with macro, and when you get to see the examples we shared with you, you can just click on the Run Simulation button and have many output data recorded automatically. Once we have inputs and output data, we can move on to examine or quantify the output uncertainty. There are many different options where we can use descriptive statistics to describe the spread or the range, the distribution of the output variables. The most commonly used ones are mean values, percentiles, standard deviations, for example. Another option is to visualize this empirical output distribution. Box plots is one of the most commonly used ones, and here I also put down the common interpretation of a box plot. After we perform uncertainty analysis, we can usually use the same data for sensitivity analysis. Sensitivity analysis, compared to uncertainty, it answers questions about what are the relative importance of different input parameters to the TA metric, or what are some of the, for example, here, if we find out that the daily user fee we calculate is very sensitive to changes in household size, then we consider household size an important parameter, and we should, when we try to improve the profitability of the project, we can try to adjust toilet capacity to serve a larger household size, for example. And if we find that the nutrient loss during transport of waste is not that important for the value of daily user fee, then in later simulation, we can try to fix this value instead of defining a distribution around it, so that it saves computational time. To perform a sensitivity analysis, we introduce here a relatively simple method called Spearman rank correlation coefficient. And the Spearman correlation coefficient basically measures the monotonicity of between two variables. On the right-hand side here, for example, if as x increases, y monotonically increases, then the measured Spearman correlation coefficient would be 1. But if as X increases, Y first increases, but then decreases, then we're more likely to get experience correlation coefficient closer to 0. So the magnitude of the correlation coefficient measures the monotonicity. If we get a value of zero, that means Y is insensitive to X. If we get a value of 1 or -1, that means X has a very important impact on the value of Y. And the signage just indicates the direction of this correlation. To calculate this correlation coefficient, we first need to, with the input and output data, we first need to rank them in the same, either in ascending or descending order. Here, I want to show an example in the Excel spreadsheet we prepared. These are the Spearman correlation coefficient calculated using the uncertain input parameters and the corresponding TEA metrics. And we can see that household size has generally the highest magnitude of Spearman correlation coefficient for variables, output variables across the board. So we can basically conclude that household size is an important parameter in these two systems. Next, please. Now we've covered uncertainty and sensitivity analysis. Just want to check in and see if you have any questions or if you're able to understand the steps to perform these analyses and how to interpret the results. Yep, it seems we have more questions regarding sensitivity analysis. I'll try to focus more on that in the Q&A section.
So now we'll be talking about scenario analysis and contextual factors and how these can change our results that you've seen so far. So contextual factors or parameters are non-technological factors that influence technology sustainability. And you can see in this figure that dietary intake and excretion is our contextual parameter listed on the left, and it has a range of values. And here we're denoting this range as this slide. So there's a minimum, a maximum, and those are the bounds for the range of values. And then a specific country's value falls within that range. And this will impact the economics of the project, as you can see on the right, as econ there. Next, please. Now we can expand the number of contextual parameters that we're looking at for a specific country. And the ones that we're considering are listed on, in this example, are listed on the left here, down the figure there. And we see that they each have different values and all influence the economics of the project. It's important to note, though, that the relative importance of contextual parameters depends on the product or the project or the product that we're performing the TEA on. Next, please. Now, in this scenario analysis where we investigate the impact of these contextual parameters, we have a list of countries that we are considering in the Excel sheet, and you can see them listed with different colors on the right in the legend there. And you can see that these contextual parameters can vary between countries. And as you may guess, that these different contextual parameters can influence the results. So the economic outcomes may be different in different countries. Next, please. And so this screenshot here shows the input that we considered for the country scenario parameters, and we'll just go through them one by one here. Next, please. At the top, you see dietary intake and excretion parameters for each country. So the countries are listed there, and then these contextual parameters underneath. And these are going to influence the nutrients excreted and the available nutrients to recover. Next, please. The next here is economic parameters. And some of the important ones here that we're going to be looking at are price level ratio. And this will influence the capital and operating expenses. and then also the nutrient market price, which can be used to help set the target nutrient price. Next, please. And then the final ones here, the four listed, are specific to the pit latrines and the urine diverting dry toilets. These are the costs that are calculated based on the price level ratio. So we used Uganda as the base example here, our baseline. We then use the price level ratio for Uganda and then each of the countries to change those capital costs and operating costs for the pit latrines and urine diverting dry toilets. And then these values are all put into the TEA model for each country. Next, please. Now looking at the country-specific results, these are listed under the results tab and they're on the left. You can see a table of the results listed here, and we're going to kind of just go through them one by one. So next, please. The first is daily user fee. And in the graph that's generated, you can see along the abscissa here, it shows the names of the countries. And then along the ordinate is that daily user fee. And pit latrines are shown in light blue, and then the dark blue is the UDDTs. Next, please. And first, when we look at this daily user costs, you might notice here, India has the lowest cost for both pit latrines and the urine diverting dry toilets. And China, in this example, under these assumptions, has the highest. Next, please. Now, the next result that we looked at for this country-specific analysis was the break-even nutrient selling price for the UDDTs. Again, the countries are listed at the bottom, and then the price per kilogram of nutrients are listed along the ordinate there. And again, India has the lowest break-even price, while in this example, Senegal and Uganda have the highest, but not far behind is China and then South Africa. In the last figure here, if you could go to the next, please. This is for the rate of return on investment. And remember here, a higher number here leads to greater return. So if we're investors, we want this number to be high. And the countries, the highest countries in this example are India and then Uganda. And then you can see that China, under these assumptions, is negative. Next, please. So to summarize, you can see that across these cost outcomes, the results can vary among these different countries. And what makes financial sense in one country may not make sense in another country. So there's some trade-offs between these countries here. And context matters. Next, please. So in this example and what we've talked through so far, we've focused on how contextual parameters influence economic outcomes. But bringing it back to the figure from a few slides ago, we just wanted to share that these contextual parameters can influence not only economics, but they might also impact other outcomes such as environmental, social, and technology. So when we expand kind of the scope or the lens of the project, what we're focused on to different sustainability metrics or different outcomes, these trade-offs can also be expanded. Next, please. So for the check-in here, our question on our poll, we're asking, do you understand how contextual parameters influence economic outcomes? So please take the time to answer that, and then we'll gauge how much time to include in the Q&A session based on this. Feel free to include any questions in the chat that you may have. All right, I think we've got our answers there. So majority of folks said yes, they understand, and some of the other folks said maybe I might have some questions. So yes, please ask those questions and we'll talk more about it. So in the last part of this talk, we'd like to tell you briefly about a process called quantitative sustainable design and a Python package that we've developed to help use this process for sanitation and resource recovery technologies. Next, please. So quantitative sustainable design is a design process that adapts to locality and project-specific characteristics to help overcome fragmentation and really to support better informed decisions. So this combines things like decision variables, like emptying frequency, technological parameters, like maybe tank volume or maybe some decay rates there, and with contextual parameters like diet, price level ratio, and some of the things we saw in the earlier example. Next, please. And then through design and process algorithms, we can arrive at design requirements, and we aim to simulate performance. Next, please. We then layer on techno-economic analysis, like we've done in this example, in this workshop, to characterize the financial viability, and life cycle assessment to characterize environmental impacts. And finally, we arrive at the sustainability indicators. And these might be things like a daily user fee, or maybe we care about some environmental things like greenhouse gas emissions in kilograms of CO2 equivalents. Or depending on the project, we can look at different sustainability indicators. Next, please. And then importantly, these incorporate uncertainty analysis and also sensitivity analysis. So QSD-SAN is a Python package that uses this process. Next, please. And so QSD-SAN is essentially a step towards making these tools like quantitative sustainable design, like TEA, like LCA, more accessible for sanitation and resource recovery systems. It's all open source and available online. These are some links here for the read the docs and the GitHub page. We've also included an example script and a guide to accessing and testing out QSD-SAN. So this step-by-step guide is in the shared folder. And if you've never worked in Python before, you should be able to start with this guide, figure out what to download, how to download it, and then work through an example. That'll show you some of the functionality of QSD-SAN. And we invite you all to leverage this package for your work, answer the questions you might be interested in answering, and help contribute to it through GitHub and through the open source platforms. Next, please. So for this section, we'd like to have a free response question, and we welcome any answers in the chat. So the first question here is, if you have not used a modeling package before, what features may make the process of learning it less intimidating? And then alternatively, if you have used a modeling package before, what features or tools helped you in learning and using it? And we'll take a few minutes just to allow you all to answer those questions in the chat. Great, and then if we can transition to the next slide. So now we'll transition to the Q&A part of the workshop. Our plan is to alternate between questions that may be in the chat, and then allow any of you the chance to unmute and ask a question. So we open the floor up. To get us started, are there any questions? Anybody would like to be the first one to ask a question in the chat, or feel free to unmute yourself. Just to, I guess, follow up on one of the questions in the chat. Oh, was somebody unmuting themselves?
Oh, that was me, sorry.
Oh yeah, please go ahead, Ruth.
Thanks. To kick it off, this is Ruth Cottingham from Durban in South Africa. A question on the QSD-SAN model. So if I understand correctly, that model will actually look at how the characteristics of the sludge are changing through the processes that it goes through. So for example, will it be able to correlate the nutrient content of the sludge to the age of the sludge in the pit, and say, you know, if I empty my pit once a year rather than once every 5 years, this is the difference in the nutrient content of the end product? Like, would it be able to do that kind of thing?
I can try to answer this question. The answer is, short answer is yes. QSD-SAN is an open source package and it's still in access development, but the advantage of that is it follows the object-oriented programming paradigm. And any model you want to incorporate in building a unit to represent this process is feasible. And for example, if you want to consider how the nutrient content in the pit will change depending on the emptying period, we can design a SAN unit or create a SAN unit object say, pit latrine. And one of the parameters could be emptying period or volume, for example. And then the streams that comes out of the pit latrine could have a varying content based on the values you assign to these parameters.
If I could just
yeah.
follow up on Joy's point. So you can make assumptions if you have data, for example, or one assumption we often make is about like the organic carbon degradation over time in pit latrines. And so if you have data from a particular region where you sample pit latrines over time, you can assign kind of a rate of degradation depending on the climate and the depth of the pit latrine, whatever you like. But we can also make that uncertain and see how much it matters. Because of ultimately you have to make a lot of assumptions to do these types of analyses. But what's helpful is if you build the models in such a way that you can run them thousands of times and kind of push and pull those assumptions, you'll find that in the grand scheme of things, maybe like 5 of your assumptions matter a lot. But the vast majority of them aren't that big a deal. They're not going to change your answer. So even with regard to the fate of nutrients in the pit latrines, or and how like pit latrine emptying frequency influences the residual amount of organic carbon that has to be managed, or the nutrient losses in the pit latrine, you'll find that only a few assumptions really are driving your final values.
We have a question in the chat from Jonathan. Have you had any experience collecting data from operational resource recovery systems and using this methodology to gain initial insight into these systems? Would anyone like to?
I guess I can touch on that. So we yes is the short answer. So we've done this certainly in our background, or my background was more in centralized wastewater treatment systems, and we did a lot on resource recovery, and we've published work in that space, and we're happy to send anything we've published on those topics. And then more recently, we've been working with the Bill and Melinda Gates Foundations and teams who have been funded through the foundation, who have developed technologies, everything from kind of household level up through more tens of thousands of people, serving tens of thousands of people. And so in those cases, yes, we work with the teams, we see what data are available, and then we try and tailor the models. But in particular, we have this approach that you start with simplified assumptions and kind of treat these technologies or these processes as a black box, and you make assumptions about what goes in, then what'll come out. So like how many nutrients will be recovered, what losses might I have, what will be the cost per cubic meter treated, things like that. And then through sensitivity and uncertainty analysis, you can better understand which assumptions are really important. And then we work with teams to try and collect data or track down data or generate data around those parameters that are really important to the costs or really driving uncertainty.
We have another question in the chat. So from Rana, the question is, using the QSD-SAN model, how much effort or time would you say it would take to be able to conduct a comparison between 2 products as we have shown with the Excel example?
I guess I can start to answer that. We just went through some work on using QSD-SAN to evaluate some technologies. And I think the short answer is it depends on a few things. One, it depends on your experience, I would say, with modeling and with Python. And we're really building it out and attempting to build it out in a way that it's really accessible to anybody. So we have provided that module that you can use to get started in it. There already are some SAN units or different units that are incorporated in there, like pit latrines and urine diverting dry toilets. So those are already in the package and included in there. And the other thing, I guess, it depends, is essentially how involved your process models you would like to use for it, and how detailed you would like those models to be. So if you want to do kind of a preliminary analysis with some of the tools that are already there and some of the SAN units that are already there and leverage those, I would say it wouldn't take too much time. But if you want to go back and add maybe some more robust process models or tailor things to your the questions you would like to answer, then it might take a little bit more time. Anybody have any thoughts they'd like to add to that question?
I can say something. Yeah, I also think it depends on how familiar you are with Python. So if you haven't used Python before, you know, there'll be that extra time to try to teach yourself how to do Python. And all of us graduate students and postdocs on the team, there was a point in time when we hadn't used Python before, and so we all had to teach ourselves how to use Python. So even if you don't have experience with these tools, there's a lot of great resources just on the internet, lots of free educational tools of how to use Python. And I think it's a really useful skill set to have to try to transition away from using Excel and try to get more into Python programming and coding. And I guess like if you want to do just like the back of the envelope estimates, you know, Excel might be the tool that would make more sense for you if you're just trying to do simple calculations. But we did show how to do sensitivity and uncertainty in Excel, but I find it to be a lot easier when you're doing it in Python because it's only a couple lines of code, and it is easier to try to do more intense modeling when you're using Python instead of Excel. So I think it just depends on like what types of, you know, objectives you have for your TEA and the types of questions that you're answering.
Yeah, I just used it this past week, and I've used Python before, but I don't have like a super strong object-oriented programming skills. And so if you don't have a strong background, I definitely recommend reading the docs and going through that carefully. I kind of just like dove into it and had to like take a step back. So make sure if you know, like they've said, if you want a very robust model that you go through, read the docs, because a lot of them have put a lot of time into putting those together for everyone.
Yeah, and I guess one more point to add with the QSD SAN. So the idea is that it will be a collaborative platform. So projects that I'm working on, I can model those unit processes and upload them. And then maybe Stetson is also working on a project that uses a unit process that was involved in my product. So then he wouldn't have to necessarily go through all of the effort to do that coding. And so we can take different unit processes and put them together to model a single system. And so if we all work together and start modeling a lot of different unit processes, then we can pick and choose different unit processes to try to evaluate lots of different systems.
Yeah, right now there's aerobic and anaerobic SAN units. So if that is part of your model, and we have anaerobic baffled reactors, so there's a lot of units that might be very similar to what you're trying to model.
And then we have a question from Sagar about how's the experience of using the model on large scale projects, such as standalone FSTPs. I assume that's fecal sludge treatment plants, but correct me in the chat if I'm wrong. And so what I'll say is conventionally we've done like this kind of sustainable design process on everything, including like full scale millions of gallons a day or tens of thousands of cubic meters per day plants, down to the single household units. And so we often do those types of projects. What QSD-SEN is enabling us to do now is to build on each other's work and make that much easier. And what object-oriented programming lets you do is to basically, if we have these units, these different unit operations, you can just pick them, like if they're already coded, you can take it and insert it into your process and adjust it as needed, but also add other units. And so that makes it a lot easier to build off other people's work, to use what's already available on GitHub. And so our work in this space and in other kind of sustainable design and large scale treatment plants and things that we've been doing, QSD-SEN and object-oriented programming is making it much easier to continue to build. There absolutely is that learning curve about getting comfortable with Python and object-oriented programming and just getting oriented in the software. But as Tori mentioned, going through read the docs, there are examples that'll walk you through how to learn to use the software. And once you're going, making adjustments, rerunning things, looking at the sensitivity to specific decisions, picking up your treatment plan and putting it somewhere else, or running a whole bunch of different configurations. What if I remove this unit operation? What if I add this other one in? What if I change the flow in this way, add a recycle, all of that? It's once you code it, you can look at many options very easily. And that's really the power of Python and object-oriented programming.
Okay, we have another question from Fiona. They said, I might have missed this. What about level of service? Does it model at 100% efficiency, or can we choose a different level of service?
So Fiona, can you just clarify what you mean by level of service? Is this like % of the population served, or
I think it's easier if I just speak.
Yeah, please. Yes.
Yeah, I mean, like usually one facility is not used to 100% design
sure.
capacity. So yeah, so
Sure.
do we account for this?
Perfect. Yes. So there is like basically you, like with any engineered infrastructure, there are these different periods, like when you design it and then you build it. And so we'll build it at a certain capacity with a certain set of assumptions, but over time we may be uncertain about its use, and so just like we're uncertain about whether a pump is going to die if we have pumping, so in year 4 or year 6 or year 8, we might be uncertain about how many households it will serve, or what people's diets will be, and things like that. So all of that can be part of the uncertainty analysis, and you can include different scenarios for population growth or attrition. All of that can be part of the analysis. And so that's one of the really nice things too, is you can play out kind of scenarios for what are the financial risks from underutilization, what are financial risks from population growth, like if you're building a system that isn't modular. So what am I going to have to do to accommodate significant population growth in one region? So all of those can play out.
And to build off of that, so I think thinking about that topic is really important, especially if you're trying to create a system that does have profit. So if we're trying to recover nutrients to sell as a fertilizer, and hoping that we'll get profit from the system, the quantity of nutrients we have to recover depends on the number of people using the toilet. And so if we're planning on 10 people using the toilet each day, and then we only have 50% of the people using it that we thought, then that's 50% less nutrients. And so maybe in our calculations from this TEA, we said, yes, we will be able to make a profit. But then if we actually implement it and we don't have as many people using the system, then we might actually go into the negative and not see a profit. Okay, we have about 2 minutes left. So if anyone has any specific questions, I can flip back to the list of topics. So if there was a specific topic that you wanted a little bit more clarification on, we can probably answer a couple more questions depending on time. So if you have more questions, feel free to unmute yourself and ask the question. You can always put the question in the chat too if you don't want to unmute.
Hi team, it's Andy here. I just wanted to jump on because you're getting obviously close to the end and there's been some nice questions there, but I just wanted to thank you guys for the presentation. I sit in lots of these and that's a little different and very technical and lots of detail, and we thank the University of Illinois for jumping on and presenting there. It was really good. So thank you very much.
And thank you all for attending. And Andy for hosting. Thanks.
We should probably wrap things up then, guys, if there's no more questions. I'm sure everyone appreciates all your time, and thanks for being a part of the conference and delivering a really interesting session. Thank you.
All right. Thank you all.
Thanks, Andy. Thanks, everybody.
And thank you all for attending.